Hello, Rifat, how are you?
I'm doing great. How about you?
Great as well. So thanks for joining me for a coffee. Do you drink a lot of coffee?
Yeah, I drink a lot of coffee, to be honest, and multiple cups a day.
And how do you typically drink it?
Well, I typically drink it as a latte of sorts, and sometimes espresso shorts.
Espresso also.
Yeah,
short.
yeah.
Do you have an espresso machine in your house, or how
Yep, I have one, and it's a real energizer. So when I'm coding and all
what
that.
What kind of espresso machine do you have? Like
I have it's a Nescafe espresso machine, a little one where you filter the coffee and put it.
So you put the beans. And
Yep.
It grinds the beans.
Yep.
Oh wow, but that's legit. That's absolutely legit.
Yep, I buy the beans from Northend that we have in Danmon here.
Yeah.
So you just grind it. It's real tempting.
Fantastic. So you will definitely like this.
Yep.
Because this is like the Nespresso. It's as good as it gets as a like fast food type of espresso. It's I think really they're really great. Yeah, I couldn't do anything without this. It's my fuel.
Yep, that's the stuff. It's actually the fuel. So
right, all right.
Yep.
Cheers.
Cheers.
So we're live, right? Video is good, frame is good. Cool, perfect. All right, so Rifat, you're here today to talk about a project that you've recently started. Actually, you've started, it's not really a project. I think you started to play around with some new tech.
Yep.
And that's WebAssembly, and that's actually very interesting because WebAssembly is getting a lot of traction these days. I hear and read more and more about WebAssembly. I've always thought like that's kind of like some side thing, but it's part of W3C since 2017, and yeah, it's being used all over. I mean, there are some frameworks now as well. So please tell me a little bit about it.
Okay, so in terms of framework, well, Microsoft first launched Blazor WebAssembly quite some while ago. So Blazor is a framework where instead of JavaScript, you can write C# code, and you can work with still the HTML, CSS parts, and then you can use C#. You can also use JavaScript as well in the same repository that you are building. So that was the first idea, but before that, we had Blazor Server. It was much like a server-side rendered framework where you would write code, but that code wouldn't run inside your browser directly. It would be compiled inside the server, and they would be sent or pushed to the front end with SignalR technology. But that isn't really efficient for fast-paced user interaction all that. So then came WebAssembly. And with that, with the rise of WebAssembly, there's another platform called Uno. Uno platform is another platform that lets you develop multi-platform apps from one single code base. And with that, it also includes WebAssembly. So how Uno did it, the approach is a bit different from the Blazor because they're using the .NET Mono runtime. And
sorry, what was that?
It was the .NET Mono runtime.
Mono runtime.
Yep.
Okay.
Yep.
Yeah.
So what you can do with it, you can compile the ECMA CIL bytecode into native machine code. That is extremely efficient because it has a compact binary format that runs inside the browser. So what it gives you is performance, near native speeds that your code will execute inside the browser as if it was a native app. So this is the ecosystem that we currently have mostly. There are other frameworks as well, non-C# ones. There are frameworks on Rust. There are frameworks that are coming up with Kotlin. We can write WebAssembly also. See, the beauty here is WebAssembly is not actually the actual programming language. It is a compilation target. That is where the difference is. So you can choose whatever language you're actually good at, and then you can choose the compilation target to WebAssembly. And there's like a generator which will compile and generate equivalent WebAssembly code from your C# code or C++ code and run inside the browser.
But it is, I mean, the way I understood it was always it's like a compiled ahead of time code. So it's like code you compile and then you deploy your compiled code, and then that's of course faster because nothing has to happen in the browser while you're on your application. However, I read they also have a chipped option. like a just-in-time compilation option in WebAssembly. How does that work?
Okay, how does that
I
work?
absolutely did not get this.
Okay, so that's a pretty interesting question. So yes, WebAssembly has two compilation targets. You can choose the JIT compiler, which is the interpreted mode. It's pretty much like how JavaScript works. You know, the code is not compiled before, just in time when it's being executed inside the browser, the code is parsed, understood, and then executed inside the browser ecosystem. But when it's ahead of time, you are pretty much compiling all the code before it's being deployed to the browser. So in WebAssembly, there are two options because, well, to be honest, there weren't two options before. We came up with the ahead-of-time compilation technology a bit later. Before, when the ahead-of-time compilation wasn't there, WebAssembly was pretty much just-in-time compiled code. But recently, with the upgrade of platforms like .NET 6 and how languages are coming forward, ahead-of-time compilation was possible inside the browser, because inside the browser is technically a JavaScript ecosystem, right, where everything runs in interpreted mode. But right now, the runtimes that we are using lets us compile our code ahead of time, so that we can come up with a package that can be deployed inside the browser. And when you're about to run the app, the necessary packages will be downloaded inside your browser and it will be stored. And then when you are interacting with your app, the code is already there and compiled. It's just going to be executed inside the browser instead of going through the interpretation and everything and all that. So yeah, we do have two different options, but the most efficient one, as Microsoft will tell you, Uno will tell you, that go for the ahead-of-time compilation. But there are some drawbacks to that. So when you're using ahead of time, the app size will increase just a little bit. Why? Because it's generating everything. Nothing's going to be executed inside the browser in runtime. So, but in ahead of time, you are generating a binary package. So you're trading a bit speed for space. So your app gets a bit larger, but you get the speed, and that's what we want. So right now, I think the era that we are living in, speed or processing or compute per second is more important than storage.
Right.
So,
Yeah. I see that. And you you built a game on WebAssembly very recently as a sort of a prototype to show how it works. What are the use cases? Like, when do you think we can go with WebAssembly to make a difference?
Okay, so WebAssembly is a kind of platform that what I've understood so far is you're supposed to use WebAssembly where you have to develop computer or CPU intensive tasks. You want to execute some intensive tasks inside your browser, such as
like graphics.
Yes.
Video, image editing.
Yes.
And things like that.
And video streaming, audio streaming, games, hybrid apps.
With some modification, it's very much like sort of visual user visuals, like applications. Like for example, I also know that for example, software that we all use quite frequently, Figma itself,
Figma,
right?
yes.
The Figma designer itself, the drag and drop component of it, and like how you can like follow others and all this. That's all WebAssembly. So do you see any other advantages of it?
Yeah.
For example, in the mobile world, right? We see mobile browsers are getting more capable and higher performing as well. So can we use the mobile browsers as sort of, operating systems to run games and editing tools and things like that?
So yeah, day by day the mobile browsers are getting more capable, because this is happening because WebAssembly was introduced to run inside modern mobile browsers. So you get to use WebAssembly in Firefox, Google Chrome, and all the modern browsers that we have there. But also, it's not that much of a huge backwards compatible. Why is that? Because WebAssembly is not trying to be the go-to platform where you can use an old browser that perhaps Internet Explorer that is now extinct, right? So WebAssembly doesn't support Internet Explorer before version 9, so there was a gap. But JavaScript will perfectly run in all browser versions and all that. So as we are evolving inside of technology, in the browser technology, to be honest, browsers now can run GPU-intensive tasks as well. It can now talk to the GPU. You can play 3D games inside the browser, right, with Unity and all that.
Yeah.
So what WebAssembly is bringing to the table is that the freedom to choose a programming language, whatever programming language, and with type safety. Because JavaScript is not type safe. It's a dynamic programming language, but in a WebAssembly, you can use a statically typed programming language. What gives you that is security.
Right.
So
it gives you security as a developer of your application, right? But what I read is it basically challenges the browser's security, because the browsers have more difficulty to understand what's actually happening in there.
Correct.
Right? So for all the malware producers, hackers, rogue people on the internet, this is an avenue to get back into the browsers and not being traced.
Yep, that is true. That is actually true.
How is that combated?
How is that combated? Right. So see, maybe WebAssembly, what you told us about, that is actually correct. But also, you will also know that the WebAssembly code that we are writing as a developer, as a programmer, is executing inside the browser in a sandbox environment. So WebAssembly, when it's compiled, it's decoupled and it's hidden from the actual browser. So the source code itself is not actually exposed inside the browser. So it's running in a sandbox environment. What WebAssembly is trying to give you is some sort of a protective layer, so that the actual code or the game code, for example, is not hackable, so that, oh, I just press F12 in my keyboard and I browse the source code inside the sources elements, and then I try to change some bits. You can't actually do that, because the actual code that is executing, that is hidden away. But yes, in terms of security protocols, as WebAssembly is a compilation target, it's not actually a programming language that we use to program stuff, the browser finds it really hard. Like, okay, for cores, for example. So when you're consuming an API, a third-party backend service, that code is still JavaScript. So WebAssembly internally will use JavaScript APIs to call the backend service. So then all the security that you want to build for your app, you can develop that, because internally WebAssembly is not going to do it on itself. It's going to rely on JavaScript so that the call can be made. So yeah, there are some vulnerabilities, but then again, it's comparatively really new platform, and it's just rising. And if you look at the history, I mean, it took 20 years for JavaScript to have the ecosystem that we have, and WebAssembly came just a few years before. So I think maybe at the speed that technology is now moving forward, it's gonna be in no time that all the security issues that the web protocols and security, everything else is gonna be implemented in WebAssembly really soon.
Right. Like, I mean, there are some limitations nowadays, right? Like, still there are some limitations, like garbage collection, for example.
Yes.
So you cannot really use it as a framework style, front end platform.
Yep.
And probably that's also a bit challenging when working with teams, with multiple developers in the same project, to make sure that certain conventions are met and all this. So it's really like, it has quite a narrow scope.
Yep.
As of yet still, but who knows where this all will go, right? I mean, JavaScript is becoming lighter, more efficient. Basically, the JavaScript frameworks are getting closer to the real JavaScript, to the native JavaScript. Now, this is sort of an addition to JavaScript. So it's getting more complex and it stays interesting, right?
Yep.
So how do you stay up to date with all these trends and technologies? Like what do you do to follow and figure out if something is relevant or not? And I mean, you have a very busy job here at SELISE, right? So how do you do that? Okay,
how do I do that? That's a pretty interesting question. So the first thing that me as a developer, when I grew up, the first thing that I was blessed with is there was no internet. The internet wasn't that available. So
I'm blessed with no internet.
Yeah, I was blessed. Why? Why? Because I'm a reading person. You see, when I have to learn a new programming language, for example, I wouldn't jump quickly to a video tutorial. Instead, I'll just buy a book from O'Reilly or somebody else, and I'll just read the book. You see, what that gives you is a good reading prowess. You get to understand information a lot faster when you're reading a lot of stuff. So when I was graduating, internet in our country wasn't that available. I'm talking about 2008, when we had little modems that we had to plug in inside your laptops and computers, and then we had internet. So, and it was expensive. I mean, 1 gig of internet costed 1,000 taka. I mean, it was really expensive for students to afford. So with that, what made us, we developers who are now working in the industry, is reading friendly. We can consume information at a great speed, and with books, you get to be exposed to a lot of details. Attention to detail is retained there. But when you're watching maybe a video, the video maker is going to skip a lot of stuff, because otherwise the video length is going to be huge and people would lose interest. So I had this habit of reading a lot, so that retained with me, that stayed with me. So when I'm not coding for SELISE, I'm actually reading stuff on the internet. And what I've done, what I found really beneficial for me as a developer, is with internet right now, everything is open source. I mean, .NET framework is open source. Uno platform is open source. Blazor is open source. So with GitHub, that's another thing, how this is increasing our development experience a lot. If you want to know about the technology, you can simply go to GitHub, download the repo, debug it inside a computer. Isn't that fantastic? But back in my days, we didn't have that. So I think that the idea that if you are into reading a lot of stuff, that will actually drive you more to read about more stuff, explore new technologies, how they're coming.
Right,
and
right.
For that, I have followed some newsletters in Microsoft. Whenever there's some new announcement, Microsoft makes new announcements every now and then. So I get notified. I just go there and see, okay, C# 11 is going to come very soon. What are the differences? Okay, .NET 5 was there, now we have .NET 6. What are the differences? Code comparisons.
Right.
So yeah, that's how I just keep it up.
I see. And then, I mean, it's always also important to try things out, right? It's good to have a theoretical knowledge, but then you need to try things out. And what I always struggle with, I always want to try out everything, right? And then I get started, and then after like 2-3 hours, I press run and it doesn't work, and I get frustrated, and I say, okay, let's go to the next one. It should work, right?
Okay.
And what really impressed me, I think you made 2 prototypes that you've shown to us recently. I mean, one is the game, and the other one is your
the photo editor,
photo editing software. What I like about this, these are actually finished. You could still call them prototypes, of course, but these are finished programs, right? These are programs that work, right, and that you can use as an end user. And they do something, so you complete that entire cycle. And I mean, what I've mentioned about myself trying out new things, that's just I think that's probably a large part of the entire population of people being interested in new tech. So it really takes a lot of additional
enthusiasm,
motivation to actually finish something up, right? And like iron out the bugs and get it to run. So where do you get this motivation from to finish things up in an innovative early stage discovery phase? Right?
Okay. So in terms of motivation, it might sound a little bit childish. So what happened is I was always a nerd since I was a child. So my dad brought me a computer when I was in my elementary school. So I was, I had, the white monitor boxes, the white CPU that was sitting inside the, the monitor. And the era of floppy disks. We didn't have CD-ROMs or the internet or all those things. We used to, when you turn on the computer, it would make like noises, like those kind of noises. So what I found interesting about the computer ecosystem is, wow, I can do that. I mean, I can tell the machine to do something. I can just give it an instruction and it will do it. I mean, that was the first kick that I got when I wrote my first Hello World computer program. That excitement that I had, like, okay, I made the computer do that. It's saying hello world, or I can add 2 numbers and display the results. So that motivation actually came really, really early in my childhood, because I had an exposure to technology. I was watching movies like Iron Man in 2008 that came out. So I think that was the moment, the prime motivation for me to pursue computer science, a career in tech. That, okay, I want to be this guy in real life, okay? I want to build machines like this guy. Jarvis, the AI system that Tony Stark uses in the movie, I want to know how you program that. So, and build. You see, what Iron Man does is he builds stuff. He builds same thing 78 times. If you look at his collection of suits, he's always improving and improving stage by stage. He has Mark 1 to Mark 78. So that ideology that you have to keep improving on the things that you have to do. There's always some scope where you can improve. So that motivated me a lot, that, okay, this is something that I want to do in my real life. I want to create stuff that is going to help a lot of people. And I think the company that I'm working in right now, SELISE, is the perfect company for that. We are building hundreds of thousands of things, and that's being used by millions of users, solving business problems, daily life problems, and we have products in the market that is, helping other businesses to grow their revenue, fast forwarding them towards a point where it would have taken a lot of time to get there. And I think this motivation that I had is being fully realized right now, where in the ecosystem that you have.
Amazing.
Yep, that would be it.
Very good. Very glad to hear that, Rifat. So, and I think, by the way, have your coffee. It's getting cold.
Okay.
So yeah, that's. I mean, I still all goes back to my, that full cycle question, right? Like finish things up, do things thoroughly, right? That kind of attitude, and also understand what it is good for, right? Because obviously when you build a game, it's pretty straightforward. Everyone will understand the output of it, or an image modification system. But if you build some complex actuary system that calculates some variables for some guy sitting somewhere in the background doing something, it gets much more abstract, right? But I think that's really, really key as a developer to see that as well, right? To see sort of, what are you outputting and how are you helping an industry, a company, to achieve more with the technology that you're providing to them. So I think that's really a very important mindset that we generally, as an industry, need to establish more. And that's why I'm curious, to figure out what are trigger points that trigger you to have this full cycle motivation, I call it. Okay. And not just, being one, part of you're always one part of everything, but just seeing yourself as that cogwheel somewhere amongst many other cogwheels, without seeing who are these other cogwheels, or even being interested what these other cogwheels are doing. I think that's a flawed thinking that I find a lot in the industry, and that we somehow have to change.
Yep. So it's actually correct. In our country and in a lot of countries in the tech world, you have developers who are working maybe in the front end side of things for 10 years. That's all great, right? But I think we currently, at the time and age that we have inside the technology world, if you don't have a full cycle knowledge of the SDLC, software development lifecycle, that how the front end connects with the back end, what is a database, how do you communicate with an API? What is an API in the first place? How do you build that, okay? So I think the key component towards understanding the SDLC is trying to build things from scratch with your own hands, not relying on something that is already built when you're practicing. But when you are working in a company, an enterprise ecosystem, there's no point in reinventing something that is already invented, right? But if you want to grow forward, I think that the only way forward is understanding the software development lifecycle. And if you want to understand that, you'll have to get out of your box. We all, at some point in our life, we create like a comfort zone, a circle where we are perfect, happy, and safe. We want to be there. And okay, I'm a super back-end expert guy. Oh yes, I'm blowing everything off, and it's all fine. But I think it's important that you also know how the front-end frameworks are built, like JavaScript-based frameworks, Angular, or the most core part of kickstarting the interest inside our mind should be trying to know your programming language better. If you're writing JavaScript, you have to learn how JavaScript executes inside the browser. How is it compiled?
Exactly.
And if you're writing C#, how is the semantic analyzer that we have, or the compiler that we have, how it understands the language that you are writing. Once you know that, you will have a clear picture of, okay, if I write such as a link queue expression, and if that can be shortened or optimized, if you know beforehand that, okay, I'm writing this code, and the C# compiler is going to understand that code in this manner, this amount of memory will be allocated for this syntax. If you know that, then you will be obligated to write better code. So I think to be a really good tech person in our world right now, it's really important to know things from the low level. I mean, the high level stuff, those are comparatively easier, I think, to grasp, but it's the low-level knowledge or the in-depth hands-on experience that if you have, that is where you shine, I think.
And then connect that to the business problem that you're solving, right? And I mean, I'm also fascinated a lot by, and that's why we have this talk about WebAssembly, I mean, by what's happening inside the browser. I mean, there's so many things that I would guarantee 99% of all developers do not know, that like how code is optimized. I think we have discussed before stubs and the optimized compiler, and then how it goes back, and like how JavaScript actually gains its efficiency, and many other things. I'm absolutely fascinated by that as well, and I think it does help you understand better when applications are performing in a certain way. Like, for example, that I used to never understand when I use a web application that is a little more sophisticated, that over time it consumes different amounts of RAM. It first builds up and then it reduces again, like how it does that and why it does that, and what are all these flags in my Chromium browser, be it Brave or be it Chrome itself, right? So what are these flags? When I set these flags, what do they actually do? I mean, there are hundreds, I think. I don't know how many flags there are, maybe you know better, but these things I think are really, really interesting, and there's so much untouched and untapped opportunity just within the realms of like how things work, and then what can be done. So so that's great. I mean, so it's great to have you on our team, and have people like you who are pushing boundaries, trying to figure out new things we might not even use at this point, maybe in the future, maybe not, but it's very, very important to stay relevant and to stay innovative. And this talk is now a first trial, right, that we're carrying out here, and the main thing is really to cater to the developer community, the developers who we are hiring, but also the business analysts. I think they should also understand this. I mean, this basic level of understanding they should have, and they should get into it, because it makes them stronger. And so if you want to join SELISE, if you want to join this type of conversations, if you want to be engaged with very, very active development, and maybe you can also say something, Rifat, before we close this. I think Rifat, you gave a very nice analogy with the bodybuilder, right? Like what we're actually doing at SELISE is we're creating bodybuilders. Brain builders, bodybuilders, right?
So that's just a little something that I'd like to tell to all the youngsters of our country who are maybe graduating right now, or maybe coding somewhere, or use coding as your livelihood. So you see, I think that if you want to grow, the first step is first realizing that you are not existing inside your comfort zone, and you have to go through some sort of a pain. You see, if you want to have abs, obviously I don't have abs, so if you want to grow your muscles, you have to go to the gym. And when you go to the gym, you're pulling weight, doing push-ups and all that, and that's not super fun. It's gonna hurt you, it's gonna make your muscles sore and all that, right? But all that pain is gonna make you stronger. So there's a saying, whatever doesn't kill you, make you stronger, right? So our brains are also muscles. So in terms of programming, the more pressure you give to your brains, the more you use your brain, the more problems you solve, okay? That's gonna make you stronger. And that's gonna increase your overall brain information processing capacity, okay? And with that comes the growth. And at a certain point, you will reach a level where you won't be afraid of anything. I mean, there's a problem, you will already know, okay, there's a book somewhere that I can read, or maybe there's a blog somewhere which explains how this stuff works. I'm just gonna go read that and just try it out inside my ID, whatever that is. So yeah, that's my advice to you. Don't always push yourself, and that's gonna be painful, but that pain is actually needed if you want to grow. So yeah, that would be it.
Wonderful, wonderful, very good. All right, so thank you very much. Let's see how it goes. Let's see how the audio quality turned out.
Yep,
and,
sure.
Let's go back to work.
Yeah,
right?
yeah.
Cool.
Thank you.